So the nice thing is in R, we can get these diagnostic plots of high leverage, outliers, as well as studentized residuals by using a simple plot function with our LM object. And so all I'm doing here is basically saying that I want it to be showing the 4 plots in a grid, and that grid is going to have 2 rows, and it's going to go 2 by 2. So you'll see it in a second. But what we'd get is we get 4 plots when we do plot of our regression object, and I'm going to walk through exactly what each of these plots is giving us. So the first thing that you're going to get is residuals versus fitted values. This is used to check for our assumption of linearity as well as constant variance. And so what we should see here is basically like a straight line that goes across, that's horizontal, right around 0, right? Because again, we want one to make sure that the variance is not different for different fitted values. And we want to make sure that it is kind of centered around 0, mean 0. Now, what we can see here is not that, right? We can see definitively that there is not really a straight line. And moreover, what's worrisome is that we can see that there is kind of a linear relationship here. So already we should be concerned. Now, the second thing that you're going to get is the QQ plot. And what this is doing is we are checking for normality of the residuals, so the distributional assumption. And if they are normally distributed, they should be going from the origin to the top right in a linear fashion. And we can see that that is not what is happening here. So already we can see that a lot of our assumptions, mainly being that our residuals are centered around 0 and normally distributed, as well as having constant variance. These assumptions seem to not be holding right now. Now, the third plot that you'll get is called the scale location. And this is kind of similar to the residuals versus fitted plot, but instead it's going to use the studentized residuals instead of the fitted values. And essentially, this is again telling you whether or not you have equal variance or homoscedasticity of your errors. You should have kind of a horizontal line, and the spread should be random and equal for different fitted values. And that's not the case here. We can see that there actually kind of seems to be a relationship where we have higher levels of studentized residuals for certain fitted values in the center of our distribution, which is not good. Fourth, we get the residuals versus leverage plot, and this is checking for potentially influential, remember that being both with regard to hat values and studentized residuals. And the way that we can kind of read that is this is like kind of a contour plot, and so we have those critical thresholds for our Cook's distances that we think are potentially concerning, one starting at 0.5 and the other starting at 1. And really what we're concerned about is anything that pops outside of those thresholds. So like for instance, observation 6 would potentially be an observation that we may be concerned about that has undue influence on our estimates.